Hello and welcome to this week's Productivity Enhancer. Earlier today I was looking at my water bottle on my desk, so I decided to see if I could design this water bottle in SolidWorks, including the bottle and the top. So here we see that bottle that I've mocked up real quick in SolidWorks, and I've even created some mates so that the top spins on the same axis as the thread pattern that I've created. So if we zoom in and take a look at those threads, you may wonder how they were created. But luckily, that's exactly what we're going to find out in this weekly Productivity Enhancer. I'm going to show you how to create threads on a part with a fairly large diameter. If we take a look inside the bottle, you can see the threads receded in there, and when this top is wound all the way down, it will wind right into where the threads meet until we reach the bottom, and then it will stop. So in order to create the top, we need to first take a look at the bottle. So here we have the bottle, and it's already zoomed in a little bit, and we need to get some dimensions from this bottle so we can know where to put the threads. So you can see that our threads are inside with this helical pattern. So let's just click on that sketch, and this will give us the information that we need. So if we zoom in, you can see this triangle right here is the profile of that thread. So if we zoom out, you have to envision that this triangle sketch is embedded inside the mouth of this bottle winding down. If we click on the helical spiral, you can get a better idea of that. It just winds itself around until it ultimately stops right here. But if we click back on sketch 3, we can see that this triangle is 1.77 millimeters, and this is the female or the accepting part of the thread. So the thread that we're going to have to create on the bottle top is going to have to fit inside of this triangle just barely. So we'll make it 1.7 instead of 1.77. So we'll make a mental note of that. If you'd like, you can always write down these figures. However, there's not too many of them, so I think I can remember them. Next, we need to know the height from the very top to where the center of that triangle is. So as we can see, this triangle is straddling this plane, so we need to know the distance between this plane and the very top. That can be accessed by clicking sketch 8, and you can see it is 7.5 millimeters from the top. And finally, we need to know the actual information associated with this thread. So by right-clicking on the helical spiral and edit feature, we get that information. So just to give you a heads up, we're going to be creating this exact helical spiral pattern on the outside of that bottle top, and that way these threads will match up perfectly. Luckily though, I do know that SolidWorks will store all this information, so the next time we bring this helix spiral property manager up, it'll already have this information in it. We do need to take note of the fact that this helix is twisting clockwise. In order for that top to fit in there, we're going to need to spin that helix the opposite direction. So we're going to make it counterclockwise when we create the thread on the top. So we can just close that. So instead of closing this bottle file, I'm just going to minimize it just in case we need to reference those dimensions again in the future. However, now it's time to take a look at our bottle top. And here we have a naked bottle top, this face ready to accept that thread. So first of all, we need to create a plane. And the first reference is the bottom of this face right here. And if you remember, it needed to be 7.5 millimeters, so we will just type that in here and accept it. Next, we need to sketch the profile of our thread. So we're going to sketch on the front plane. Make sure that that plane that we just created is highlighted, and then we can just draw that triangle on the side here. So once that triangle is drawn, we can dimension it as such. And then we'll just add some relations to make it all equal. So let's just make sure that this point is in fact 7.5 from the top. And we can accept that dimension and exit the sketch. So now we zoom out, grab our bottom view, or top view, doesn't matter. So now we open up a sketch on that plane we just created, and we'll select the circle tool and draw a circle from the center and snap it to the outside and accept. Then we can bring our model back in. Let's just grab front view again. And we can exit the sketch, and now we're ready to create that spiral, which will be our thread. So go down to helix and spiral, and we'll double check these numbers, but they should be the same. 3.5 millimeters for the pitch, 2.5 revolutions, starting at 180 degrees. The rotation on the thread on the bottle was set to clockwise, so we're going to need to set this to counterclockwise so it will fit in. So we can go ahead and accept that, and you can see that helix is sketched on the outside of that bottle top. Next, we get to use the Swept Boss Base tool, and for our profile, we're going to use that sketch of the triangle that we created, and the path is going to be the helix and spiral. Once we accept that, it will create that thread all the way around. And all you'd have to do next is bring this bottle top into an assembly with the actual bottle and create the mates, and you're all set. So that's one way to create threads on larger diameter parts. Of course, since there's so much functionality built into SolidWorks, there are a few different ways to get the same results. However, this one has a pretty quick workflow and doesn't require a lot of time. So thanks for watching this week's Productivity Enhancer. Until next time.